here's another example we're going to tackle. We want to find the derivative for this function f of x equals the square root of x. Okay, so that's our function right here. So we're going to use our limit definition. So we'll find the derivative, and then we'll find the slopes at the points 1, 1 and at 4, 2, and we'll talk about the behavior of f at 0, 0. So we'll get to that. First thing we need to do is find the derivative. This time I will make sure I write all the pieces. So remember, the derivative is the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. And that's just the definition that we had up at the top. So now we're going to start plugging in what we need. So the limit as delta x approaches 0. This means to take x plus delta x and put it into the function. So that's going to be the square root of x plus delta x minus f of x. F of x is just the square root of x all over delta x. Now, we want to evaluate this limit. We want delta x to approach 0. We cannot just plug in delta x because we would be dividing by 0, which is the same problem we had in the last one. So we're going to need to use some of our limit tricks that we talked about last week. For this one, we're going to rationalize the numerator. So this will be the limit delta x approaches 0. And what we're going to do is we're going to rationalize the numerator. So I'm going to multiply this by x plus delta x plus root x. I'm going to do that on the top and bottom. Okay, now the denominator, don't do anything with that, just leave it. Okay, the numerator, you're going to FOIL that. The square root of x plus delta x times the square root of x plus delta x is x plus delta x. These are conjugates, so your middle two terms are going to cancel. And then we have minus root x times root x is x. So now that we've rationalized, you'll notice that x minus x cancels out. And once those cancel out, then we just have delta x over delta x, so then those will cancel out. So we are left with the limit as delta x approaches 0 of 1 over square root of x plus delta x plus root x. Now remember, we're taking the limit as delta x approaches 0, so now we can plug in 0 for delta x, this is 0, and we are left with 1 over root x plus root x, which is going to be 2 root x. So the derivative of our function is 1 over 2 root x. Now, the other thing that it wanted us to do when we go back to the original problem is to find the slopes of the graph at the points 1, 1, and 4, 2. Okay, so I'll pull this back up here. So remember, we just found that our derivative was 1 over 2 root x. So at the point 1, 1, the way we find the derivative, or the slope of the tangent line, is we're going to do the derivative at 1. We're just going to plug in 1, which is 1/2. Okay, so the slope of the tangent at the point 1, 1 is 1/2. At 4, 2, the slope of the tangent, or the derivative, we're just going to plug in, not 2, we're going to plug in 4, because that's the x value. Sorry. 1 over 2 root 4, which is going to be 1/4. Now, I want to illustrate this for you a little bit. So let's pop over to Desmos. I don't have Desmos up. Just give me half a second here. Okay, so this function was the square root of x. We were looking at the point 1, 1 and at the point 4, 2. Okay, so if you were able to think about drawing the tangent line at 1, 1, it would have a slope of 1/2. And then the tangent line at that point 4, 2 would have a slope of 1/4, which you can kind of see from the graph looks about right. Now, we also need to discuss what's happening at the point 0, 0. Okay, at 0, 0, if you draw a tangent line there, notice that tangent line is going to be vertical. So our tangent is going to be x equals 0. It has a vertical tangent line there. Going back to this formula, if we tried to plug in at 0, 0, if we tried to plug into the derivative, 1 divided by 2 root 0, we would be dividing by 0, and we can't do that. That's undefined, which means we have a vertical tangent. So we would say at 0, 0, there is a vertical tangent. So work through the problems in 3.1. 3.1a, we're going to be continuing with derivatives, hashing out this, working through it a little bit more, but it is a super foundational thing. So make sure you're working hard on that homework. Check your answers and results on Calc Chat and bring lots of questions on Monday because this is a really foundational piece for this chapter and for this whole semester.